So, we're going to talk about sequences. They're called arithmetic and geometric, okay? So when I'm trying to figure out if something is arithmetic as a sequence, the question I have to ask myself is, can I add the same positive or negative number each time to get the next term? If I can, that's arithmetic, and I need to find the pattern. If it's not, then I just write no, and I'm done for right now. So for instance, what I'm going to do is I'm going to go from term to term, and I'm going to say, okay, what do I add to 4 to get to 7? Well, I add 3. Well, then when I go from 7 to 9, I add 2. Or when I go from 9 to 12, flip it over, okay, I add 3. Am I adding the same number every time? No. So this one is not arithmetic.
Morning.
Good morning. Nope.
Nope, absent?
Nope, absent.
Okay, thanks.
So, as I'm going to these, now just because it says can I add, okay, technically I could subtract. Like if I look here, okay, it's -2. And if I go between the next two, it's -2. If I go between the next two, it's -2, but it's the same every time.
So yes.
So this is a yes, and then I write down why it is. I'm going to add -2. I always, when I'm doing an arithmetic sequence, I have to use the word add. You can't say subtract 2. That's not what an arithmetic sequence is. It's adding something. So if it's a yes, I have to put a reason behind it. I can't just say yes or no on all of these and just go about my business. So, when I get to the next one then, on number 3, is that going to be an arithmetic or not?
Yes.
Ooh, I'm hearing different things. Yes and +3, okay. Or add 3. You could say +2, that'd be okay. But yes, I'm going to add 3 each time. Okay, I'm good to go there. Ooh, negative numbers. I'm hearing no already. Let's see here. Let's see, from -6 to -5, that'd be +1. If I owe somebody 5 and now I only owe them 3, oops, that's +2. As soon as I see any different ones, that one's done. So the negatives can cause their own little interesting point to come up here. Let's see. If I owe somebody $5, now I owe him 3, how much did I pay him back? Okay, I paid him back 2, so that's helping me. Well, now I owed him 3, now I only owe him 1. Still +2. I owed him 1, ooh, now they owe me 1. Still +2. So, since those are all the same, okay, that would be a yes. Now, some of you may say, well, what if I'm not sure what the number is between two of these? How am I supposed to figure this out? Yeah, I can either, if I was really wanting to think about this, I could do it a couple of different ways. I could either try some different numbers until I found the next number in the sequence and then kind of work it from there. Or you could subtract the numbers as you're working with these, but that can get tricky because then some of you would be like, well, that says -2, so that can probably be more of a problem than it's going to be a help. So just try to find that pattern. Okay, what about 6? Okay, yeah, if I owe somebody $9 and now I owe him 12, sounds like I spent or I borrowed $3 more. If I owed them 12 and now I owe them 15, again I owe them 3. But like we mentioned before, we never use subtract on these. If the numbers are all the same, I just say I add.
What if it's like 2 numbers are the same and then like the last one's different?
No, they all gotta be the same. Yep, you can have the first couple going great, and then you get to that very last one, and you're like, oh, So yep, it has to be the same for every single one. So finding if it's an arithmetic sequence is one thing we can do. Another thing we can do, well, that was nice of me to put 2 in a row to do the same. If you get to the next section, maybe we find you to ask you to find the next terms. So let's say we're doing 9. Okay, what am I adding each time to get from one term to the next? Okay, I'm adding 4. Now, one thing that's nice is they said find the next 3 of the arithmetic. These are all arithmetic. Close. Okay, if I keep adding 4, and then adding 4, and then adding 4, those would be my next 3 terms. Once you find the pattern, you can go to the last number that you see and just do that same thing. So like if I go to 11, because 10 is the same thing as 9, I don't know what I was thinking. What am I doing each time in number 11 to get from one number to the next one? Okay, so I'm adding -2, or you can look at it like you're subtracting 2. So if I do it that way, what are the next 3 numbers in the list going to be? Okay, 14, then another -2, and then another -2. So that's kind of what we're up to here. Let's move down here. Let's find one that's a little more interesting. 16. Oh. Actually, let's do 14 and then 16. I like both of those. Those both look interesting. All right, so 14. Looks like I'm heading down here. What am I going down by each time?
5.
Okay. So we're doing the old -5. So if I start at -3, once I have the pattern, once I have the pattern, if I want to get some help to make sure things are going okay, I can. And the nice thing about these calculators is then I can just keep doing the -5. I don't even have to type the other part in. So if you're asked to find the next sequences and you already know the pattern, just keep doing the pattern. But, ooh, 16. But I think I'd already heard somebody say what the... Okay? Because when you're doing these, okay, if you absolutely positively are not sure, but you know there is going to be a pattern because it says it's going to be arithmetic, you always can take the bigger number minus the smaller one or the one before it to figure out what the pattern is. So since we're adding 2.5 each time, at that point, if I need the help, I could go to the last number in the list and just add 2.5. And then to that number, just add 2.5. And you see where I'm heading here. And add 2.5. So there's lots of things the calculator can help you with, but a lot of you, I think, have the number sense to be able to handle something like that. Speaking of decimals, what about 17? Yeah, we're just going up by 1. So I just keep going, okay, 7.1, 8.1, 9.1, and keep working them that way. Are there any other ones on this side that you want to take a peek at? Because again, the pattern's just what am I adding each time, and then just keep doing that. Okay. So again, adding is arithmetic. Now, if you flip over, the other side introduces us to our other type of sequencing, which is called geometric. So a geometric sequence is found by saying, what can I multiply the previous term by to get my next answer? So the idea works the same. It's still a pattern, but now instead of adding, it's multiplying. So, again, like it says, in other words, can I multiply by the same whole number or fraction, can be a fraction sometimes, from term to term as the pattern continues? So determine here, we're going to blend them. Determine whether it's arithmetic, geometric, or neither. Ooh. So let's see. Number 1. Now, you're like, well, to get from 1 to 2, I might add 1 or I might multiply by 2. You know, what's the deal? But if I look at the next one then, if I'm looking for the same pattern, if I times by 2, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, you're like, okay, so I'm multiplying by the same. If you're multiplying, it's geometric. And the pattern is times by or multiply by 2. And sometimes we'll just kind of play with these back and forth until we find one that maybe works or maybe that none of them will work. We don't know. So, this next one looks interesting. 9 times something to get 14, probably not going to happen. Let's see, that'd be plus 5. Ooh. And then that'd be minus 8. Yeah, it's definitely not arithmetic. Definitely not geometric. Okay. There's no real rhyme or reason to that guy at all. So that's just a neither, and I don't need to find any more. I'm just done. So once you see that it's not going to be one of those patterns all the way through, it doesn't work. Ooh. Let's see here. We have a fraction to deal with already. 2/3 to 1/3. Well, I could minus 1/3, but then 1/3 minus 1/3 would be 0, so that doesn't make any sense. Multiply by 2/3 to get 1/3. Ooh. Let's play with this. Let's see here. Let's get the calculator up and see if it can help us out a little bit. What if I do... Oops, I got to put my parentheses in here if I'm going to use the calculator. 2/3. Let's see. What if I... divided by 2? Ooh. Math, enter. Okay. Divide by 2. Let's try this. What if I divide the next one by 2? Okay, it's a decimal, but let's see if I can get it into a fraction here with math, enter. Ooh. We may have a winner here. Divide by 2 one more time. Math, enter. Sweet. Okay. You're like, but wait a minute. You said it was only add or multiply. We're dividing. Ooh, this is something we can learn, though. It is going to be geometric, and I'll explain why. You're like, well, we're dividing. When you divide by 2, that's the same. If I turn that 2 into a fraction, 2/1, that's the same as multiplying by its reciprocal. So if I were to bring the calculator back up and do 2/3 times 1/2 Oh, I see what I did. I'm sitting there going, what did I do? I hit multiply. Got to pay more attention to the buttons that I'm hitting. I'm like, because that's supposed to be working. Divided by 2. That's better. Math, enter. And I get the 1/3 back. And that would work all the way down. So we're going to multiply by 1/2. So you're like, so wait a minute. How does this work again? So if I end up dividing by a number, that's the same as multiplying by its flip. So like if I'm dividing by 2, it's like timesing by 1/2. If If I were dividing by 6, it would be like timesing by 1/6. So I can sometimes get some weird geometric ones. There won't be a lot of them, but it's just one of those things. If nothing else seems to be working, try dividing by some number and see if that ends up helping, because that might be the pattern.
So it's divided by 3, it could be 1/3.
Yes. Yep. Okay, so let's see here. Let's look at this next one. -2 to 5, I don't think I'm multiplying by any normal number to get that. -2 plus what would get me to 5? And -2, I owe somebody $2 to them owing me 5. 7. Does 5 plus 7 give me 12? It does. Does 12 plus 9 give me 7? It does. So my pattern's the same. Is this arithmetic or geometric? Arithmetic, because it's add. What about number 5? Yeah, it looks like we're adding 6 each time. So that would be arithmetic. I get the plus 6. Again, we're just looking for patterns.
Can we just put the plus 6?
Yeah, that's okay. Yep, it absolutely is okay to do. Now, number 6, this would be add -48, but then if I do that again, it would be 0, so it's not that. Can I divide 96 by something to get to 40? Yeah, 2. Now you're like, I don't know that 96 divided by 48 is 2 off the top of my head, Hardy. What's the matter with you?
Yeah, but 48 and 24 and 24.
Yeah, and you also could just divide them if you wanted to and go, ooh, it looks like 2. So here, if I divide by 2, then you're like, I wonder if that would work again. Let's see, -48 divided by -24. Oh yeah, that's 2 again. But like we just got done doing in the one directly above it, if I'm dividing, okay, that still would be geometric, but I'm multiplying by the flip, because any whole number I can make a fraction by putting it over 1. So if it does that, I can handle this. So let me get this back out of the way. Let's find a couple of interesting ones here. All right, number 7. Those don't look far enough apart to be arithmetic. Oh, but they all say geometric anyway, so never mind. I don't have to worry about that. Okay, if I'm not sure about a pattern, just divide them if you know they're geometric. So 648, yep, divided by -216 is going to be divide by -3, divide by -3. So if I'm just looking for the next 3 terms, take the last term, which is 72, and divide it by our pattern, -3. So I've got -24, and then just keep dividing. Divide by -3. It's 8. And divide by -3. Now, if you get a decimal, okay? If you get a decimal, let's try to get it into a fraction. So if we get it to decimal, let's math enter it and see if it's simple. Okay, that's better. Because it's easier to see the pattern with that than it is with the decimals. And that's going to be true for any of these. So like if I'm doing number 8. Again, let the calculator do your big work here. If I divide, okay, it looks like it's -5 that we're dividing by. So I go to my last number, 1. I divide it by the -5. And again, if it's a decimal, I try math enter. Okay. -1/5. And then just keep dividing that. -5. Again, I don't like the decimal. 1/25. One last time. Really don't like the decimal. like the fraction much better. And I get my next term. And it even works with fractions. I'm just going to get you set on number 9 because then I want to show you these other ones where if you're just looking for a particular term, how you can make that go a little quicker. So you're like, I don't know this one either. You know, 1/16 to 1/2. Okay. 1/16 divided by 1/2. Now, here, math, enter, enter. Okay. So it's 1/8. So you're like,
That's 16 divided by 2.
yeah, this one actually, when you're doing it, you're like,
And then the number 8 is you just multiply this by 5.
So, yeah, if you divide by 1/8, what's the flip of 1/8? Okay, so this is geometric. We're multiplying by 8. So I could keep dividing by 1/8 with this if I wanted to. That'd be okay. I could do 4 divided by 1/8. I think some of you'd get spooked out when you saw that, though. You'd be like, wait a minute. Divide by 1/8, it's 32. Yeah, if you divide by a fraction, it's going to get bigger. Because you'll notice if I get to 4 and I just times it by 8, I get the same thing. And then I could just times by 8. And just times by 8. So the numbers are getting kind of big. But if you just keep dividing by that number, that's okay too. But if I'm looking for the pattern, whatever I'm dividing by, I'd multiply by its flip. What if it asks me for like the 7th term, you know? How am I going to do that? Basically the same way we've been doing these. Once I see the pattern, what do you multiply 2 by to get to 10? 5. Since we saw the negative, it'd be negative. Okay, so my pattern is multiply by -5. Type in my last one. Oops. So that would be, I already have 3 terms, that's my 4th term. Times -5, there's my 5th term. Mercy. Times -5, there's my 6th term. Last one. Times -5. Whew. Whew. Okay. Thank you. So if my numbers keep increasing like that, I can just multiply by that value. Well, what if they're decreasing? Well, we already talked about when we're doing these how you can do the divide thing too. So one last one here, and then we'll get you started with some of the homework ones. If I'm not sure of the pattern, okay, I can look and say, okay, so that's divide by 4. Now that's the same as multiply by 1/4, but it's not asking me what the pattern is. It just wants me to find the 6th term. So if that's all it's asking, I'll take the last one, and I'm going to start dividing by 4. So they already gave me 3, so this is my 4th term. Here comes my 5th term. And one last time. There's my 6th. Oop, decimal. Don't like it. How do I fix the decimal? Math, enter, enter. 1/2. I'm done. Okay. So again, this just comes back to letting the calculator help you find the pattern and then just working your way out to the end with it. So, in the packet that we're working with, underneath here, let me shrink this down. On the first side, it says determine if the sequence is arithmetic. If it is, find the common difference, which is just a fancy way of saying find the pattern, and the next 3 terms in the sequence after the last one given. Now that's only if it's actually arithmetic. If it's not, then, well, you don't have anything left to do. But if you do, we need to work on finding that. So, okay, yeah, it looks like I got a pattern here of add 30. So, it is arithmetic. The pattern is plus 30, and it says find the last 3 terms if you can do this. Okay. So, I start with 122, and I'm just going to keep plussing by 30. So, 152, and another 30 is 182, and another 30 is 212. And I'm done. But the biggest thing here is finding that difference, learning to see how this works. And if you're not sure, again, on the arithmetic, just as one more reminder, you can always take the term after it and subtract the one before it. So like here, I could look to see, well, let's see, is there a pattern here? 78 minus 48. Okay, so here my pattern would be 30. And then I do a 48 minus 18. I'm just subtracting the one before. Ooh, that's plus 30. Okay, let's make sure. 18 minus negative 12. 30, okay. So it works. Again, it's plus 30. That's kind of weird. It's the same one again. And once I see what the pattern is, then to find my last 3 numbers, just start with the number at the end and keep adding 30. And adding 30. And adding 30. So that's how the front's going to work. It's arithmetic or nothing on the front one. You're not going to get any geometric ones on that front sheet. So that's kind of just, again, looking for patterns and things. When you get to the back, when you get to the back of that sheet, okay, determine if they're geometric. Again, geometric is your multiply / divide. Common ratio, again, is just let me know what the pattern is. But they're only going to be geometric if they're anything. So if there's a number I can multiply by, great. Otherwise, divide the numbers in the list from end to beginning and see if there's a pattern with those. So you're like, all right. And then for the rest of them, it's just some multiple choice on figuring out if it's arithmetic, geometric, or neither. But let me move down here. Play with 21 and 22 for a second here. I still want to see what the rule would be. You're like, oh, really, Hardy? Yeah. I sort of want to know how this works. Now, for some of you, looking at this in decimal form might help. For instance, 21, you may look at that and go, fractions, I'm done. No clue. Okay, let's do this for a second. Even though we're not a big fan of fractions. All right, so we got, okay, 3/2 is really 1.5. Let's see if this makes a little more sense here in a minute. Okay, that's 2.5. So now my pattern is 1, 1.5, 2, 2.5, 3. What am I doing each time? Yeah, we're just going plussing by 0.5. So if I'm plussing by something, I'd like to know if you pick arithmetic or geometric what the pattern is. But otherwise, that's it. Trying to see some that look like they'd be funny. Let's see. Let's look like we're doing on 22. Forget about the 4s for the minute since they're all the same. If you were going from 7 to 5 to 3 to 1 to -1, I'd be doing -2, and then I just keep the number on the same, bottom the same. So I'd be adding -2/4. And since I'm adding, okay, it's arithmetic, but I still want to see the pattern. And if you're not sure about the pattern, just keep reminding yourself, I always have my backup plan. I always can take any pair of numbers in the list, so if I want to do the first two, I could do 5/4 minus 7/4. And actually, you're like, well, that's not the same as this. Remember, if I reduce that fraction, it'd be -1/2. And if I do that with any pair in the list, so if you're testing for arithmetic, this is your method you're going to go. Okay? It's -1/2 every time, so it's arithmetic. Okay? If I can divide backwards, okay, it's going to be geometric. If I can multiply, it's going to be arithmetic. And then all the rest of these are just the same, doing that same thing. Tomorrow we'll play with these some more. Okay, so get a start on these. There's going to be a little bit more with this tomorrow, but we're just going to add a little. And then we'll be back into the review by Wednesday, getting ready for the unit test coming up on Thursday.